Okay, so hi guys, my name is Saransh Mishra and my USN is 1bi21cs132, and today I'll be giving you a brief presentation on the topic voltage to current converter and current to voltage converter. So what actually is a voltage to current converter? Well, it's a kind of an electronic circuit which is designed to take voltage as an input and produce corresponding output in the form of current. And this voltage to current converter is also known as a VI converter. So in other words, we can say that an electronic circuit that produces a current which is directly proportional to the voltage applied to it is actually known as voltage to current converter. So many of you might be thinking as to why do we need this? So well, for instrumentation purposes, where we need to have analog representation of certain physical quantities such as weight, motion, pressure, etc. This voltage to current converter is actually needed. So sometimes it is essential to create current which is corresponding to proportional applied voltage or definite voltage. So for this purpose, voltage and current converters are used. So now I'll be talking about voltage to current converter using an operational amplifier. So many of you guys might be thinking or wondering as to why do we need an operational amplifier? Well, sometimes we need to store a precise amount of current respective to the voltage applied to the circuit. So this is what operational amplifier does, as written over here, is that it sustains a precise amount of current by applying the voltage which is essential to sustain that current throughout the circuit. So there are actually two types of voltage to current converter. One is floating load voltage to current converter, and the second is ground load voltage to current converter. So first, I'll be talking about the floating load voltage to current converter. So as the name suggests, the load resistor is floating inside the converter circuit. So as you can see, the load current is floating around inside the circuit. So that is the RL, or the load resistor, is not linked to the ground. The voltage Vin, which is the input voltage, is given to their non-inverting input terminals, and the inverting input is driven by the feedback voltage which is across the RL resistor. The feedback voltage is actually determined by what? The load current, and it is in series with the Vd, which is also the input difference voltage. So this circuit is also known as current series negative feedback amplifier. So now I'll be talking about the relationship between the current and the voltage applied to the circuit. So here on the left we have the circuit, with regards to which I'll be explaining this formula. So applying Kirchhoff voltage law in anti-clockwise direction, we have Vn is equals to Vid plus Vf. Since Vid is tending to zero voltage actually, since the gain A is very large, we have Vn is equals to 0 plus Vf, 0 because of this. So we can say that Vn is equals to Vf, and Vn is equals to Ri R1 I naught, since Vf is equals to R1 I naught, and therefore I naught, on substituting the values and taking R1 to the left hand side, we have V in I naught is equals to V in by R1. So now I'll be talking about the ground load voltage to current converter, which is a second type of voltage to current converter. So the V to I converter is also known as Holland current converter. Here, one end of the load is always connected to the ground. So for the circuit analysis, we have to first determine the voltage Vin, and then the relationship or the connection between the input voltage and the load resistance. I mean the load current. So here we have the circuit on the left, and for that we need to apply a Kirchhoff current law at the node A. So at the node A we are applying Kirchhoff current law in anti-clockwise direction, and here is clockwise direction, and here again it's in anti-clockwise direction. First, we can assume or say that I1 plus I2 is equals to I1 plus I1 plus I2 is equals to IL. From here, we can substitute the values of I1 and I2, which is V in minus V1 by R and V naught minus V1 by R, which is equals to again load current. So here from this, we can like substitute, I mean not substitute, just cross multiply these R to the right hand side, and we can get V in plus V naught minus 2V1 is equals to ILR. From this formula, we can actually get the value of V1, which is equals to Vn plus V naught minus IL by 2. Um, so we actually know that for a non-inverting amplifier, gain is equals to 1 plus RF by R1, and the resistor RF is equals to R, which is also equals to R1. So we can say A is equals to 1 plus R by R, where R and R get cancelled, and the value is equals to 1 plus 1, which is equals to 2. Hence the voltage in the output will be substituting all the values, and from here we can get IL, which is equals to V in by R. So now talking about the uses of voltage to current converter, it is mostly used to transmit signals over to a long distance. The reason behind it being due to internal resistance, the voltage may get reduced. That's why it is mostly recommended to convert it into current, since um, in long distances current is not that reduced because of Kirchhoff current law, and that's why we use current to transmit signals to a long distance. And they are mostly used in instruments like RTD and thermocouple. And some of the typical applications of voltage to current converter are in AC and DC voltmeter, diode, LEDs, and Zenith diodes, etc. Now I'll be talking about the second part of my topic, that is current to voltage converter. So what is current to voltage converter? A current to voltage converter is something that produces output voltage with respect to the corresponding current which is taken as an input. So an I to V converter is used to convert varying current into equivalent output voltage. And one of the major advantages of using this current to voltage converter is that it is used in measuring instruments which can measure only voltage, not the current, and we want to measure the output current. So now I'm talking about the current to voltage converter using an operational amplifier. So as you can see, there's an operational amplifier embedded right in between the circuit, which has three types of input current, that is IX, I, and IRF. Now applying Kirchhoff current law in this node B, along this direction, we have IX minus I minus IRF is equals to 0. Also, the current flowing through the input terminal of operation amplifier is actually almost equal to 0. Hence, we can say that taking IRF on the right hand side, we have IX equals to IRF, and then applying Ohm's law in the circuit, we have V naught is equals to IX into RF. One of the major applications of a current to voltage converter is that it's used in photodiodes. And what does a photodiode do? It's simple. It is used to measure light intensity. So the output of a photodiode sensor is the current, which changes proportional to light intensity. Another advantages of operational amplifier circuit is that the voltage across the photodiode is almost kept constant at zero voltage. And one of the most application of an I to V converter is as photodetector amplifier to measure the intensity of light as shown in the diagram. Here we have a photodiode which is connected to this circuit, where an operational amplifier is also being used, since we have already done what's the use of it. Um, so a photodiode which is in reverse biased, point B, that is the inverting terminal of operational amplifier, is at vital ground potential, and a negative voltage VDC and a negative potential VDC is applied to the anode of the photodiode. When the light is focused on the reverse bias photodiode, a photodiode IX starts glowing. It is proportional to the intensity of light falling on photodiode as shown. The current acts as the input to the IV converter, hence the output voltage proportional to the photodiode is produced, which we have already done in the previous slide, that is V0 is equals to IX into RF, that is RF into IX. In this way, an I to V converter provides amplification to small photocurrents IX. So what it does is that if provided a small intensity of light I, what it does is that it amplifies it so that it is like evenly spread throughout the circuit. And this is what simply this photodiode actually do, and what's the use of this current to voltage converter in this circuit. So yeah, thank you. This was my PDF PPT for ADE, and yeah, thank you so much.